Hello. Testing 1 2. Alright. Oh. Alright. So, before I ended the stream, like an hour ago now, I was working on doing window audio API loopback, capture the audio right here. I'm at the beginning of initializing it right here, get audio endpoint. So now we're just basically going to set up this code. I have to do a bit of conversion because this is C++ and I'm in C, but it didn't take that long. Now that I've got the basic idea of the API down, it should be pretty quick. Do a bit of renaming here. I think that should be good. I need to look at this wave format EX. Yeah, so it says samples per second. That's probably what I'm looking for. So I actually don't think I need to access that. I think I can just create it right here. Requested during completion. What is that? Oh, right here. Ref times per millisecond, so it's just $10 million. Just doing. I was reading a Stack Overflow post while I was eating lunch about getting low latency audio, and it uses this very same setup, or nearly. Does it have initialize? No, it doesn't do initialize, it just does activate. Alright, well, I'll just copy this and do 10 million to start. Let's see if that worked. So I need to do activate, initialize, get buffer size. Okay, I'm gonna get the buffer size, print that out, and that's a good point to test it, I think. Oh yeah, and each of these I'm gonna need a vtable call. I forgot about the conversion. I wonder if it says how many channels there are. Nope. Hey! Holy shit, I have not talked to you for like a week actually. How are you doing? Ramadan Steve. I'm just mangling this Windows API code right now. I'm actually having a ton of issues. Yeah, actually I should just settle for copying this code first. Samples per second. Got class at 4 p.m. man. What about you? I'm trying to make an audio visualizer, or I've got a program that renders shaders. These are all the shaders I've. This is like my shader bank. So now, oh, okay, buffer frame count of 44,100, samples per second 44. Oh shit, it's actually working. So basically this renders shaders, like I can go shader 0, and it renders it whatever. It's got capture commands for capturing images and rendering to videos, so you can do like 4 or 8K renderings. Like I can set the window to 4K, and it'll just render at 4K even though it's way too big for my screen. And I can capture a 4K image, and it'll lag, And oh my god, did it crash? Let's check. I've never tried this before, so this is actually oh no, it did. It just took a really long time. Yeah, I probably shouldn't have made it render at 4K 60 FPS. That was probably... I'm surprised it didn't drop frames, but okay. That's cool doing C++ today using Microsoft Visual Studio. Dude, that's what everyone's using right now. Yeah, I'm still stuck in the old days with C, but that's just because I like it more. I actually have to do extra work now because Windows is designing their API for C++ and I have to access the virtual table directly. But wait. Did this actually render a 4K? Holy shit. 30 megabyte image file. Oh boy. Okay. So this can actually render 4K images. That's... Okay. So this is the thing I don't understand. So there's all this stuff where people are like, our games support 4K rendering now, and I've always thought, wait, can't you just render at 4K? It'll just be way too slow. And this, yeah, this is literally, you can render, anyone can render at 4K. It just might not be in real time. And actually looking at what that did, it didn't lag when it rendered. It lagged when it did the PNG encoding and saved the 30 megabyte image because it's saving to a hard drive right here. That looks so sick. Thank you. This is so, then what I'm trying to do in this stream is I'm trying to add audio capturing, so you can basically read what frequencies of audio are coming through the speakers, so then you can do reactive audio stuff. Like I did a bunch of this stuff before on Shader Toy, but you can only do SoundCloud songs, and this actually doesn't work anymore. So I like the best thing I think would be something like this, where it just does whatever's coming out your speakers, just reacts to whatever's coming out your speakers. Yeah. No, none of these are sound visualizer. Yeah, see, it doesn't even work anymore. So that's the thing. This only played specific songs. I'm thinking the whole idea of reacting to having a visualizer that reacts to whatever is playing is like be awesome to have. And you know what? This is actually working pretty well because it's telling me it's 44K samples, which is exactly what my audio is. I'm just wondering, I gotta look at waveformat EX, I gotta see if it's stereo, giving stereo or mono. I think it should be giving both ears. And channels, yeah. Okay. But yeah, this stuff is probably like some of the hardest programming you can do, dealing with the APIs directly. And yeah, I'm looking at this Stack Overflow post on getting low latency. The goal is to hopefully have it like react somewhat quickly so that it's not like because right now in this example it's actually reading the audio a second behind, so the reaction will actually be like a second behind, but it's just for testing right now. So hopefully you can just change the buffer size and it'll go lower latency automatically. I think that is what happens. This person is saying that as well, that you can supposedly get 10 milliseconds latency, which is insane. That's like 100 frames, that's the equivalent of 100 frames per second. This is very good. I don't even need that much. I actually want a bit more because, so the interesting thing is the math about doing this is you run a fixed Fourier or a fast fixed Fourier transform across the audio data to get the frequency data, but the smaller buffer size you put in, smaller sample size, the less frequency range you get, the less lower frequencies. You need farther ranges of data to get those bigger, longer wavelengths. And it's like, so actually, like, you have a benefit actually of running it a second behind if you can detect those much lower frequencies. The other thing is, though, the human ear can only detect, like, it can't even detect that much, so it's not a huge thing. Alright, I should just be able to get the service, set the format, start, get next packet size. I wonder if this waits. Oh yeah, okay. Well, next packet size. I have like 20-30 millisecond delay on my audio monitor when I use plugins like Auto-Tune. Okay, alright. Yeah, won't even notice unless someone told you. Man, I had to use a different driver for FL Studio one time, and it was like 100 millisecond delay, and it was brutal. Like, it was actually playing keys, so I think that's when it's brutal, when you're pressing a key, and then like it's like a whole, like, you definitely notice it when you're hitting something and then it does it. I don't know. I'm just looking at what this does, so the issue is if these packet sizes are different, it means this fixed fast Fourier transform is going to be different, which means, like, I guess I'll build up the packets until I get the size I want. That's what I have to do. For the trash, for instruments, you need it to be pretty much instance. FL Studio is like, it has everything I need. So that's just, I've never really, like, I've looked at other things, but like, it's like the whole thing of like, it just takes time to learn how to use them, and it's like, if you already know how to use one, you can't really bother to learn another. You know what though, I think, yeah, this is all I need to do. I can just call this start, set format. I'm almost wondering if it's faster for me to just type this out, since I have to fix so much of it or change it. One thing that bothers me about this is it won't work on Linux when like all the other stuff I've made does, but sometimes you gotta make exceptions. It's Focusrite audio interface. That's my audio driver. Studio made no sense to me until I met a kid. He's tripping on acid, he produced beats. Brought me to his place and he said, sure, I was, he taught me how to make beats from recording FL Studio. Oh my god, that's, yeah, one of the things, you know, my friends used to, like, man, you can just download the demo of FL Studio on anyone's computer at multiple people's places we've gone on the computer and downloaded FL Studio and just made shit beats. It's like, it's such a fun thing to do. Actual duration. I don't think I need that. So I'm doing my own rendering and then I'm just gonna read the audio as it goes. My sync. Oh, okay. This expects you know what the sync is. Oh man, you got tons of kits? That's like the key. Just collecting instruments. Get back to got an hour, shower and eat. Cheers, man. Have a good day. Have a good day of classes. So I don't need to do this sync set format. I just need to do audio client start. Let me know if you get this working. Hopefully I will today. I'll message you. Peace out. Alright, so then right here we want to call actual capture. Alright, so this is going to be the difficult part. We're going to need to build it up in a buffer. I'm gonna convert it to floats. And I need to figure out how to parse this wave format. 8 kilohertz, 11 kilohertz, 22 kilohertz, 44 kilohertz. Yep, I know about all these. Average data transfer rate in bytes per second. Block alignment equal to n channels 30 bits per sample divided by 8. Alright, don't need to worry about that then. Bits per sample equal 8 or 16. I don't think a lot of people are using 20 or 24-bit audio. I'm not sure though. $20-bit sample size in a 24-bit container. I can just make this extensible and just count how many bytes. That should be easily possible, since I'm going to convert to float anyways. Size in bytes for extra information. Alright, should be good. Should be enough then. I'm going to create a float buffer of the values. So I think I'm going to do, let me calculate this. Let me assume most people are going to be on basically every person is going to be on 44K kilohertz audio nowadays. So what's a value that divides by that? Okay, I'll do this, 44 N samples, so it'll have 100 millisecond delay it, or it should. Alright, so we're going to set up the audio buffer here. If it's smaller, yeah, I don't know what I'm going to do if it's smaller, but we'll figure it out. This is going to be samples per second divided by 10. I'm going to make it 5,000 just in case they have, like, just to support 48K kilohertz audio in the future. Successfully initialized. I'm going to put out a message that's like initialized audio with buffer of alright. So then even though our audio array is smaller, I'm actually going to compress the data into that. Oh man, I forgot that there's multiple channels as well. Well, I'll figure it out. Let's just try this for now. Alright, so we need to get the packet length. Let me copy the data. So, num frames, okay. You can actually give it multiple frames in one. Go through a while loop, reading the audio data. So it's read it all. What is P data? The byte buffer, okay. Oh yeah, I'm gonna need to clean up as well. If audio initialized. I'm just doing this now because I just remembered that I forgot it. I don't want to add it. Sure I don't forget it again. There's a specific order I need to release them. Oh, I gotta release the enumerator up here. Ah, screw it. It'll clean itself up. Seriously though, the program automatically releases all of the libraries when it exits, so it's exiting there, it doesn't matter. It is good practice, but I'm just working on getting this working right now. And I'm just looking, I have to actually release it here each time it runs into an error, and that's going to run into a whole bunch of checking. It's already released and a bunch of bad stuff, so then I gotta process the data here and then do release buffer. So I am not going to do any fast Fourier transform or anything on this. I'm just going to try feeding in the audio data at first. See how it looks. I'm just going to assume that all the audio data is 16-bit. Audio bits, or audio to a Boolean. Doing different processing if it's 16-bit or 8-bit, and I'm also going to output here. I'm thinking I might just copy I wonder, is the data signed? Scale to a fixed point representation. Signed, yep, okay. I also need an integer for audio channels. So I think I'm just going to do left ear right now. Basically just only read in audio data from the left. What I should probably do is combine them or average them. Take the max maybe of each. I'm not sure. Besides maybe just feeding in both separately, I don't necessarily want to do that. I kind of want to keep it just looking at it though. I'm gonna packing this in like this actually. I would have to create a custom function for getting the audio sample. Let me see actually. GLSL float arrays packed. Vector. Added is vector. Base alignment and array stride are set to match the base alignment of a single array element. Yep, that's what I thought. Okay. So that was why I was doing vector anyways. So then I guess I could just feed in both. That's 8-bit, not supported right now. I actually need to stream this in. Okay, there we go. So that'll set the audio data. I actually need to add 4 to this and the number of audio channels to this. And I gotta hope that I'm actually using 16-bit audio right now. Oh, compiled. Okay. Come on. Alright, shape 0, audio.glsl. 32-bit audio. Well, shit. Huh. Oh my god, it's using my microphone. Look at this. You can see it lighting up. Ah. That's so interesting. Okay, so it's actually getting my microphone and not, that's not right. Shit. It's cool that it's working. And it's actually detecting, damn, that's wrong. And it needs to support 32-bit then, I guess. Wait, I'm thinking about that. Is that actually right? Isn't this supposed to... Or an audio stream from the default audio capture device. Oh, okay. Oh my god, this is capturing a stream? I'm looking for loopback recording. Played by open a stream and loopback mode declines. Required modifications are in the call. Get default audio endpoint method. Change the first parameter from eCapture to eRender. Zero to stream loopback. Wait, is that actually all? Oh yeah, that's all you need to do. Oh, I think it's working. Let's try with a buffer of 806. Oh shit. It is doing 48K. Why is the buffer so big? It's an 8 megabyte buffer. Why is it so big? Maybe I can't trust end samples anymore? Let's see. change this shader to just output the X. Didn't read that. Is it using 32-bit audio? Yeah, it is using 32-bit audio. Okay. Let me stop this. Okay, so it is. It's reading the audio. Start and stop the audio. It starts and stops. Let me check something. How do I bring up the old sound settings for Windows? No. Yeah, man, there used to be this window, and I hate how Windows has changed. It's changed for the worse, seriously. Oh my god. Anyways, I swore I was using 60-bit audio, but I guess I'm using 32-bit. Okay. So, how do I tell if it's floating point then? I don't think the waveformat EX said. Maybe it's waveformat extensible. Adaptive delta pulse code modulation. We set to 32. Look for coefficient pairs. Oh my god. It's a lossy compression format. Holy shit, I swear to god if it's using this. Hold on, let me look at this buffer size. 8 kilobytes. Hold on, 8 kilobytes. What in the... Divided by 4,800 samples. Gives you 167 bytes per sample. What is it doing? Anyways, let's check what the format is. F6544. 54534. So it's, yeah, it's not PCM. Oh my god, if it's this adaptive pulse code modulation. So annoying. Here we go. Format PCM, wave format IEEE float. Say what any of these are. They said who? You're bald? Congratulations. Holy shit, look at all these formats. What in the... You're kidding me. 65534 is incorrect input? Yeah, bullshit. Wave format extensible, of fucking course. It's a custom Microsoft format. Are you kidding me? WSAPI decoding Microsoft adaptive PCM. Of course they have their own audio format. ADPCM overview. Capture buffer, sampling. Oh my god. This is why no one makes a lot of audio capture programs. Oh man. Lossy compression format that's implemented for X Audio to provide additional features. Achieve compression ratios up to 4:1. Maybe if you called them, they would give you more info. Oh, that would be funny. Calling up Microsoft on stream. I think I can actually do that. Only available for Windows. Yeah, of course it is. It's a Microsoft. My head is like a monk. I swear there used to be, Here it is! Holy shit, this is exactly what I was talking about. Okay. Dude, it's 16-bit! What the fuck, it's 16-bit audio! Oh my god, what? It's 16-bit audio, but wait, what? If it's 16-bit audio, then why is it 32-bit? I fucking hate Microsoft, man. Oh god. Really? Two channels? See, I thought that, but it's giving... If you look at what this, 0xFFFE is the code I got, it's wave format extensible. Which means, if you look... Probably must be against. An example is format of extra information is the Microsoft Adaptive Delta Code pulse modulation. Why so many formats? This is the same thing for dealing with microphone inputs and webcam inputs. What are you trying to do? I'm trying to do audio feedback. I've got the basics working. If you see this, it stops when I stop the audio. So it's like, it's doing the basic thing, but now I actually need to get the actual audio data. Okay, so I'm just assuming Let me actually look this though. It might not be that. No, no, never mind. What? Like Shader Toy, kind of, except Shader Toy is only for SoundCloud stuff. So actually, if this was adaptive pulse code modulation, it would be this. Maybe I'm doing something wrong. Get default audio endpoint, activate. Get mix format. Maybe it's not get mix format. What's iAudio client 2 and 3? Huh, they do less. Good format. Yep, this is correct. Okay. So this is really interesting. Everything seems to match up in that it's 4800 frequency, 2 channels. The 32-bit audio could totally be because it's 16-bit and 2 channels. But what is the 65534? The waveformat extensible? That's like... constant format. Well, it's having more than 2 channels or higher sample resolution than allowed. Oh my god, wait. So I should be able to fix this. Or not, I don't know what I'm saying, fix this, but there's 44, going to this 44k kilohertz. Wait, I wonder if I can actually change this on stream. Hold on. just in case this messes up any of the audio. Application may stop working. Do you want to continue? No. Close. Try again. Oh, I think it's talking about OBS shit. Yeah, never mind. Yeah, I can't change this on stream. So yeah, I should look at getting 48 kilohertz working. Number of bit precision per signal, multiple of 8. Block. Which channels are present? Provides additional support. Alright, so I gotta cast it to waveformat extensible. Alright, man, I'll see you around, Zedhu. I'm not sure I even understand this stuff myself, but I'm learning it. I think it's going to give me 32 as well. I think it's probably right that it's actually split up. Yeah, I actually do think it's going to be 16 bits per channel because it's bits per sample, and each sample has 2 channels in it, which is 16 bits. Okay. I will be right back. I'm going to go get some water. Okay, let's put some music back on. I forgot to unmute the desktop audio as well, so there's that. I can't trust the front page of YouTube anymore. It's like sometimes show nudity and stuff. So trying to get into practice of hiding that. This is really quiet. Hey, Vegeta. Don't have a second monitor? Nope. One big monitor. Man, YouTube and Google search has just gotten horrible. How do you even survive? I find it easier to just alt-tab between things. Or just click down here. I'm normally not doing two things at once. Alright, this will do. This will do. Okay. So I'm not going to worry about whether or not the format's extensible. I'm just going to do a thing that says here, only works with PCM audio. Used to have 3 monitors, 1 died, so I'm on 2 right now. Ooh, that is sad when a monitor dies. Bits is going to be the bits per sample divided by the channels. That one is dedicated to Discord. Now that I'm looking, I don't even have room for a second monitor right now. I could stack it up on it. I could put my second monitor on my PC. But I don't want to do that. I used to have a second monitor and I didn't use it, so I moved my stuff and I just never put it back up. Oh, this is why it's giving me garbage info, because I'm feeding in the wrong value. It's actually audio samples I'm supposed to do here. Okay. Oh my god, I actually think I had the right thing here, kind of. I'm the 1,100th YouTube sub. Congratulations. Thank you for subbing. Congrats on hitting 100 subs. Whatever. I hope people learn something. I don't put a lot of effort into my YouTube channel. Okay, I'm only gonna support 16-bit because I'm lazy and this is something that already isn't working on Linux, so I can't really be dedicated to Oh, one sec, my cat's upset because I put my chair where she sleeps. My cat would love if I just sat there and patted it for like all day. So I think I'm going to try running this through Fourier transform now. Let's see if this compiles. Do I have any errors? Oh, it's good. Fourier transform. So this is where I'm going to want to set up the data. I'm not going to want the data packed like this. I'm going to want it just as a direct float array. Yeah, so I'm going to actually do some kind of custom almost encoding for this. Instead of this, I'm going to do float 1,000 floats. Or actually, I might just do 256. So I'm going to do that by packing them in here. And then to access I'm going to do it AF for access float. Way to access it is, I believe you can access vec4s as arrays, so I can do divided by 4 I mod 4. That should be it. Here I can do GLSL is quite the language. I'm not sure this will even compile. You will see though. So then, float data is no longer going to be packed in there. Fourier transformation. And I gotta allocate it here. New Fourier transform. The size is actually in vec2s. I'm just going to do this very small sampling to start, and then I can fix it up as it goes. I believe that copies it back. Yep, okay. I'll perform the fast Fourier transform and then upload that data. Looking pretty much like noise. I think I need to sample much bigger. Yeah, that looks pretty much like noise. So what I'm going to do is I'm going to set up this buffer system again. It actually writes to a buffer. I actually don't need to add this each time. I can count the max samples in this. That's a lot more efficient. And just make sure this isn't going too loud. It doesn't seem too bad. Heading to bed now. Have a good night, man. Oh my god, it's 2 a.m. Have a good sleep. I don't think I'll be that much longer. I have all the audio input working for your transform. It should just be getting the right frequencies now. Right sample size. then here I want to resize that Fourier transform buffer into. You can actually do this in place. Assuming this isn't smaller. I should replace this I just in case there's another for loop out there that it conflicts with. I guess I can just do nearest resizing for now right here. I also can't remember, do you do zeros? Yeah, I'm pretty sure you do zeros each time. That means I should make the audio buffer size twice as big. Just put in zeros there. And then I think for the audio, I should actually do these as vec2s. Let's try this for now. This is going to be right. they need to be together. I guess I can just put them in Vec 4s. Or I could just ignore the phase data. That's honestly probably the best thing. Now I need to convert the index. That should do. Well, let's see if it works. Oh, it crashed right away. Before I could even read. Audio buffer grid. Something here. Oh, I'm not resetting OP. No, not that. Something from a Fourier transform or something here. Yep, it's the Fourier transform here. Okay, let's check this. It's probably not a power of 2. Or 800. Yep, that's not a power of 2. 2 power of 2. Huh. Crashed. So if I 36 is a power of 2. size is half. CP size times 8. Oh, it's not a size argument here. It's supposed to be false. I wonder if it's taking too long to read the data or something. Oh my god, it's Stack Overflow, isn't it? Stack Overflow. So I could increase that, or decrease this. Okay, that's much more reasonable. Alright. Now we're actually converting it. Huh, I don't see anything. And multiplying this by 1,000, scaling it up. Oh! So it looks like it's repeating the same stuff over and over again. And definitely looks like I'm not reading this correctly. Oh god, what was that? Okay, so it stays white even when the music isn't playing. That is wrong, very wrong. The buffer size divided by 2. Ah, it's wrong, but it's right. Let me try just the audio data without the Fourier transform. I think what I probably need to do is average the Fourier transform over time. wonder if the result isn't ending up in D here, because it jumps between D and O. My Fourier transformation is broken. Could be. Oh wait, this is working. On each side here, got the different frequencies. I wonder if a sine transform would actually look better. This is a lot harder than I thought it would be. Well, actually I didn't really know what to expect. I think what I'm going to do is average these. Try making the audio lower latency. Oh yeah, that's actually working really well. You can tell it's the fast Fourier transform because it's mirrored. Mirrored, but it's a little bit different. I think I might feed in the same data there. You can see it doesn't include the exact same ones. Does it? Let's see what the phases look like here. So I'm going to put the frequencies on one side and the phases on another. Let me try listening to something different. Try listening to something that has a lot more bass. Oh my god, it's working. It's rough, I think it could still be better. Yeah, so it works a lot better if the Fourier transform actually matches up. That's so interesting. Definitely more testing to do with this, but so far I'm very happy with it. This is a basic frequency spectrum of what's currently playing. Alright, I will be right back. I am gonna go and get some more water, maybe eat something, get some more blood sugar. I will be right back shortly. And actually I can close all these now because the audio loopback is working. Alright, I'm looking at this and thinking about this, and I think I'm still going to want to do a pretty good amount of testing. I'm going to want to convolute this. This is doing nearest sampling. I'm going to want to actually blur. Part of the reason these are so noisy right now and changing so fast is because I'm not blurring them together. That's going to be changing this for loop into an actual thing that interpolates between the points almost. And then I think I might even change this from 256 to like 64, because you're not even going to want to use that high of a depth frequency map. And I actually want to get down to building an actual audio visualizer, and I just don't have time to do that for the rest of the stream. So I'm gonna end the stream here. I am very happy with this progress. We got feeding in the frequency data. The fast Fourier transform is working. It's generating actual good data that you can tell maps to the maps to what the songs are actually playing. I'm very happy with it. Thanks to anyone who watched the stream. This is my first programming stream in C for a while, and pray for plenty more, because I'm going to be doing a bunch of examples for my game engine. And actually, this code for the shader render used a bunch of stuff from my game engine. So get ready for much more of that. Thanks for watching. Hope everyone has a good day. See you around.